Well, so certainly, engineering and science practice for centuries have been based on data. From observational data, people develop physical theories, and then from physical theories, we develop mathematical and computational models and use those to make predictions. I think what's different perhaps about data-centric engineering is where data enters into the cycle and the availability of kind of rich sources of new data that affect what you can do with data. So I think, in some sense, we're certainly not about throwing away physical theories, first principles, physical laws, which may have been, which I view essentially as distillations of centuries of empirical observations into these very kind of beautiful, you know, kind of compact and very predictive, objects, predictive mechanisms. But with that, we want to augment these kinds of models, these predictive models with data that maybe reflect the particulars of a given engineering situation, constitutive relations for which we don't really have first principles justifications, phenomena that are too complicated necessarily to be captured easily by all of the kind of physical principles that we have, and to customize our ability to simulate and model things to very complicated settings where the question is not so much, what are the physical laws at play, but about the description of the problem itself, the geometry, the interactions, all those kinds of things. I think that's where rich sources of data really have a new role to play. So I think there's a whole range of problems that one could imagine treating with data-centric approaches. One, I think, is perhaps sort of classical, but is the notion of inverse problems. And you have a model, but there are aspects of the model that are unknown, parameters, inputs, boundary conditions, so on and so forth. And then given available observational data, you can decide, you can learn those parameters. You can come up with better descriptions of the parameters and thus reduce uncertainty in the model and the model predictions. You can even use that system to help decide what data should you acquire next. What are the most valuable observations? Kind of assign information value to potential future observations and then decide what to go off and acquire. That's an optimal experimental design question. I think that's another kind of problem that very much is at this intersection of modeling and data. I think a journal like the DC Journal sits at a very interesting niche. What we're talking about with data-centric engineering is not, it builds upon a lot of pre-existing pieces, but it's a kind of a new synthesis, if you will. It certainly builds on all kinds of engineering journals that are domain-specific, that talk about modeling and prediction and design. It builds on math and stats journals that develop a lot of the core methodology. It builds on ML conferences and journals that also develop a lot of interesting methodology and new ways of harnessing data. But bringing all those pieces together and kind of focusing them on problems in engineering, open challenges in engineering, engineering practice as opposed to kind of purely academic pursuits, I think is the intersection at which the journal sits. And I think it is actually particularly nice that the journal's open access because a lot of the audience, I hope, is practitioners in industry who may not always have, the support of a large academic institution in its library. So having that kind of free accessibility is really important for these ideas to have impact. I think the audience is really, I can imagine two, perhaps three groups. One certainly is academics who perhaps work on methodology, sort of mathematical and statistical methodology, abstraction, but with an interest in engineering impact. And I think that's sort of a broad class of people. People in engineering domains that have discovered or are starting to kind of awaken to the power of data-driven approaches within their engineering discipline. And those could be academics, but also kind of third group practitioners, people working in industry at all levels, whether they're kind of in research groups within industry, whether they're in kind of really deployment, development, very kind of customer focused groups in industry. I think they also should be interested in this journal because there may be case studies and lessons and ideas there that should be relevant to their goals. So reproducibility and kind of open data and all these things are, as you know, kind of very broad and I think widely recognized as important in science and engineering. They're also, I'd say, complicated issues because I think when you talk about, say, in the context of DCE, reproducibility, does that mean making codes for models accessible? Does it mean making data sets accessible? But simply making codes accessible is not really the whole battle, because what exactly does it mean to make code available, and what exactly does it mean to make it accessible? Do you put your source code on the web? Is that enough? Do you need to have things that compile? Do you need to include all the configuration files that let people run the code? What if software technologies change, compilers change, platforms change? Is the code still useful to someone 5 years from now, 10 years from now? It's not entirely obvious, I have to say. So even how we define reproducibility and how we achieve reproducibility are some, I think, big questions. They're certainly important to DCE. I think they're also important more broadly. But these are things that as a community, I think we can maybe have some input on and some contribution to.